In 2020, Norway rolled out a new national curriculum. And one of the big changes in this curriculum is that Python, or programming, has been given a central role. So Norwegian children will learn programming concepts from when they start in primary school. First with games, then block programming, then text programming, for the most part in Python, and finally using code to solve mathematics problems. There's a lot of great things about this. Python is a powerful problem-solving tool, and learning to code in school can help pupils get started with more fun and realistic problems earlier in an engaging way. But it also puts a lot of pressure on the teachers. Suddenly, in 2020, a lot of Norwegian teachers were expected to know programming in general, Python syntax specifically, and how to use it in the classroom in a meaningful way. So I'm Marie. I'm a PhD candidate, and my research is on low-rank data mining methods for temporal tensor data. But as you may have guessed, that's not the topic of this talk. In addition to research, I've also been teaching. Specifically, for the past almost 5 years or so, I've been teaching Python to teachers, helping them to get started with programming, possibly for the first time ever, and to start to figure out how it can fit into an already jam-packed teaching schedule. Oh, and Python isn't specifically mentioned in the curriculum, by the way. But it is what the pupils will be tested on in exams, and it is what most of the textbook cover. So in practice, Python is what a lot of the teachers need to know. And the teachers that I've encountered in my courses, they've had a lot of different experience levels. But a vast majority of them had little to no coding experience. And some of them even felt pretty strongly about coding and computers in general, just not being their thing. So there was a noticeable range of different background knowledges and motivations among the teachers going into the courses. And learning a whole programming language in just a few weeks with no previous familiarity, while also having to learn how to teach it and how to teach with it, that's a lot. And our courses could naturally not cover everything. So our objective was to demystify programming and algorithmic thinking, to introduce some basic Python syntax, and to demonstrate how coding can enable engaging mathematics projects, with the ultimate goal of providing the teachers with the tools and motivation to both get started, but also to continue the learning on their own. Now, sadly, this project has come to an end. But its main goal of helping teachers, or anyone really, to get started learning Python is still very relevant. And I've learned so much from working on these courses and talking to so many inspiring teachers. So my goal today is to share a little bit of what I've learned with all of you. So when you're new to coding, it's easy to picture the process looking like this. You start with your blank code editor, and your destination is finished code that runs and produces the correct output. And then you just walk straight ahead. Write one line of code at a time, from start to finish, until you arrive at your destination. That's not really how it works, though. In reality, you have to navigate a lot of hurdles to get to your goal. Hurdles like, it's a complicated problem, where do I even start, fog? Or maybe an enigmatic error message enclave, or the even scarier wrong result, but no error message hollows. And there's usually also a lot of smaller, but still quite frustrating obstacles, like the Isles of Incomprehensible Indentation, or the Forest of Forgotten Imports. So a more realistic path looks something like this. Or let's face it, it's more like this, right? And learning to traverse such a convoluted path and navigating hurdles like this, that's essential to coding. So it should be part of the lesson as well. So the first challenge that I encountered is how to communicate more than just the finished code. And in my case, the learners are also teachers. Teachers who are new to coding maybe, and curious about what coding even is, and what it looks like, and how it can fit into the classroom. So it's even more important to show them the whole journey of coding. And when I use static slides with completed code on them, I risk giving the false impression that coding is about the final destination. But really, it's all about the journey. So the lesson drawn from this challenge is to try to use interactive live coding as much as possible instead of just static slides. Live coding lets me talk through the entire process of creating the code and to encourage active learning by having the learners write along with me. This puts some demand on us as educators. We have to be prepared, and we have to have a plan for what we want to cover to make sure we stay on track, because it's very easy to lose track when you're live coding, and we need to take it slow. But more importantly, when live coding, it's crucial to show more than just the writing of the code. Don't talk in silence. Talk about all the choices you're making and why. And guide the learners through the entire journey of creating a program iteratively. And make mistakes. It's important to show that making mistakes and getting error messages is a natural part of coding, and not just some weird, annoying thing that beginners will eventually stop doing. I like to prepare a few pre-planned mistakes for every lesson, and I usually also make plenty of my own unplanned mistakes. And when the first error message of the first lesson appears, I always mark the occasion. Yes! Our first error message. Now we're really coding. Improving your skills as a coder isn't as much about ceasing to make mistakes as it's about getting better, faster, and more confident at finding and fixing them. So it's important to show this as well. Another valuable tip when live coding is to sometimes stop and ask for a prediction before you run the code. This technique has shown to improve learning in other STEM fields as well, and I have good experience with it from teaching programming. One possible explanation for why it works is by forcing the learners to make a prediction. They have to confront any previous misconception they might have had and are more likely to reflect on what they've learned. So when live coding, I like to sometimes stop and ask the room either for an answer or for everyone to raise their hand for their prediction, or if I teach digitally, I'll use a poll. Either way, it's important to have some interactive element to your live coding. But just watching someone else code and listening to them talk about it is usually not enough to get a thorough understanding of the topics or to retain the information. Talking about code yourself helps you test your own understanding of it, generalize the concepts, and retain the knowledge. Discussing your code with a peer is also a great way to learn from and share knowledge with fellow learners. Pretty much everyone working with code knows this. I mean, if we didn't think it was important to discuss code, well, there wouldn't be so many of us here at PyCon. But another challenge that I've encountered is that talking code does not come natural to beginner coders. And in fact, it can feel pretty intimidating, particularly if a learner is struggling, which is unfortunately also, when talking about a code, is the most beneficial. So one thing that I've done a lot is to ask the learners to sit together when working through exercises. Remember to talk about your code, I'll say. You learn more if you discuss your mistakes. And then stand back and listen to absolute deafening silence, uninterrupted by a few nervous taps on the keyboard. Sometimes the more confident learners will start talking, but again, they're not the ones who need it the most. And after a while, I realized that I was being very unfair. I was treating the act of talking about code like something I just expected everyone to just know by themselves, with no practice. Even though I know it's super difficult. I mean, I find it difficult to talk about my code, and that's literally been my job for years. So the lesson that this challenge has taught me is to include some exercises that encourage talking code specifically and not just implicitly. Because it's important to acknowledge that talking code is a skill, just like writing code, so we should practice this skill too. And again, in my case, my learners also happen to be teachers. So it's even more important that they practice this skill because they will definitely have to talk about code in the classroom. But how do we do this? Now, that's a tough question. And unfortunately, I don't have a comprehensive answer for you, but I have tried a bunch of different approaches. And out of those approaches, I can share the two that has worked well for me so far. So the first is something called A-B exercises, which was introduced to me by my former colleague Jonas, who was inspired by pair programming and other group solving exercises, but wanted something more contained and with more structure. So the idea is that you prepare a set of 2 exercises that are similar, but not exactly the same. And you call one exercise A and one exercise B. And then you split the room in half. So one side is exercise A, and one side is exercise B. And you give the learners a limited time frame, but stress that it's not crucial to get the exact right answer, just to get some attempt at an answer. And then when time's up, everyone from side A finds a partner from side B, and vice versa. And then everyone talks through the code and the problem they were trying to solve. Does the code work? If so, how can you be sure? And if it doesn't work, how do you know it doesn't work? And you have some idea where in the code the problem lies. I like to have a few example questions on the back of the exercise sheet to help guide the discussion, but really the important part is just to practice talking about your code. For the exercise itself, I find that it's nice if it's pretty straightforward and only require 1 or 2 concepts that the learner is already a little bit familiar with, so they don't get stuck easily. Because it's not really about the code, it's about the talking. And it's also nice if the exercise has a clear goal, preferably with even some example output, because that gives a nice starting point for discussion. A shorter approach to getting the learners talking is something called pair instruction. This has been discussed in several academic papers. I'll give you the short version. You start by giving the learners a brief introduction to a topic, and then they have to answer a multiple choice question about that topic that's designed to cover common misconceptions. So the ideal scenario here is that about half of the learners are likely to get the right answer. And every wrong answer stems from a common misconception. And after answering, everyone gets to turn to their neighbor and discuss what they chose and why. So this gives the learners a chance of practicing articulating their reasoning. And then after a few minutes of discussion, everyone gets a new chance at the exact same question. So for the multiple choice question, it's good if the learners have to commit to an answer before the discussion. So I like to use sheets of paper with some checkboxes that I collect afterwards, but you could also just have everyone raise their hand or use a digital poll. So whether you use something like this or A-B exercises or something completely different, I think the important part is to acknowledge that talking code is a skill. And it's okay to find it difficult. And it's important to practice it. So one of the best feelings when coding is that feeling you get when you run the code and it works. It's exhilarating and highly motivating. But as I talked about earlier, there's often a lot of hurdles to get to that point. Hurdles that are exaggerated for beginners. And a lot of the learners that I've encountered are feeling pretty intimidated by coding in the first place. So getting them through those hurdles and giving them a taste of that sweet, motivating feeling of accomplishment as soon as possible before they give up is a huge and important challenge. And one way to soften these hurdles is to stick to very straightforward and short exercises and examples that don't require any setup. But in my experience, this can quickly lead to having mostly exercises and examples that feel a lot like coding just for coding's sake, and not like real-life problem solving. And like I talked about in the beginning, I want to show the teachers that they can use Python to solve curriculum-relevant problems, and that coding can open the door to using maths to solve more real-world problems. And problems like that often require that beginners get a lot of step-by-step instruction. And often, a lot of the steps are really just boilerplate to set up for the actual problem of interest. So here's an example where the main point of the lesson is to just see that you can use a for loop to design a simple algorithm to explore some data. And we see there's a number of code lines here, but if I mark in gray the lines of code that are not directly relevant to the main point, we see that actually most of the lines of code are not directly relevant to the main point and are more like boilerplate. And if I were to write an exercise with this as the goal, I would need a lot of instructions. And a lot of the instructions would be relevant to the boilerplate. Chances are that if a learner spends the majority of the time following tedious instructions for necessary but dry and technical boilerplate, the boilerplate will start to feel like the main point, instead of the actual task you wanted them to engage with. So the lesson I've drawn from this challenge is to use the Use, Modify, Create framework, or UMC, introduced by Irene Lee and her co-authors, which splits projects into 3 phases: use, modify, create. So for the use phase, the learner gets some code that runs and produces some output. And the goal of this phase is to use the code to solve a problem or answer a question. And because the code already runs and it produces some output right away, the learner gets to start by experiencing that flow of coding, instead of starting by being immediately stuck. And then in the modify phase, the learner gets to modify the code a little bit to solve a slightly different problem. This helps them generalize, and it's also very motivating to make some changes in the code and see that your changes affect the output. Finally, the create phase, the learner gets to create their own code. And this doesn't have to be completely from scratch, depending on the experience level of the learner. And it should be relevant to the previous code in some way. So a simple example could be, you start by running some code that uses turtle to draw a simple shape, like a square. And then you modify the size and color of the square. And finally, you create your own custom shape with turtle. A nice thing with UMC is that you can use it to give learners more interesting problems earlier. They don't have to understand or remember all of the technical details to get started on the relevant part. And you don't have to follow these 3 phases completely in order. It's perfectly okay for a learner to move around a little bit between phases several times, even in the same project. So if we look at that earlier example, with UMC, we could just give the learners this code right away for them to have fun with. And they can move gradually from using the code to answer a question, to modifying the functionality of the code a little bit, to adding some more advanced functionality, to finally writing their own code. And for each of these steps, they get some visual feedback in the form of an output plot. Here is how the finished exercise sheet looks. I'll put this on GitHub if anyone wants to look at it closer. You may have already used UMC yourself. I know I did, without really thinking about it. When I learn something new, I don't usually start with the blank code editor. I usually go to the documentation or to Stack Overflow and find a working example. And then I copy the snippet into my code editor and run it, make sure it works, and then I modify it a little bit to suit my use case better. And I repeat this a few times, each time understanding a little bit more, until finally I feel confident enough to just go ahead and write my own code. I'm pretty sure this isn't a unique strategy to me. Maybe it sounds familiar to some of you. So it makes sense that this could be useful for beginner coders as well. I hope that you've gotten some inspiration for your own teaching. If you're interested in reading more, here are some great resources that I found helpful. I will put this on GitHub. I'll also put all code examples and exercise examples prepared for this talk together with the slides at GitHub. And I want to give a quick shout out to Yngve for his excellent origami skills. So to summarize, it's important to communicate the whole journey of coding. It's also important to remember that talking code is a skill that takes practice, and you can use the Use, Modify, Create framework to help beginners get started with more interesting projects earlier. Thank you.
So thank you, Marie. There are a couple of questions for you. So let's see. The first one. It said we can't produce it on the screen. No. It was, how many teachers do you have in your classrooms?
That's a good question, and it does vary, because I've done some different courses, but we've eventually sort of landed on trying to not have more than like 25 at a time, because it's easier if you have smaller groups. But yeah, it's varied. There's been bigger and smaller groups. Some courses we've had have been sort of evening courses that teachers have signed up for, and then others have been where sort of the schools have sent them on the courses. And then we say how many we want at one course to give them the proper learning experience. Thank you.
If you can give her. Yeah. And then we have another question. See, here it says, what do you think about commenting and how to avoid being pedantic?
About what?
About commenting. I don't know who made the question. If you want to... I made it, but now it was about the comments. So yeah, like commenting out the code, I'm assuming, right? Yeah. So what do you think about commenting out the code and how to avoid being pedantic, being neat?
So commenting, like adding comments to your code, you mean? Yeah, I think that's a good thing. I tried to, like we spent some time talking about algorithmic thinking in the beginning of the course. So sometimes we will write the comments first and then to flesh out an algorithm. and then fill in the parts and sort of discuss how the comments, like if you can't explain what you're doing in a comment first, then you should probably think about it a bit more before you start coding, that kind of thing. So, yeah. And how to avoid being pedantic, like to be sort of too verbose, yeah, writing too much. Yeah, that hasn't been that big of a problem in my case. Usually it's more about trying to write something out at all. But we try to focus on the comments adding something and being helpful. The idea is to write the code and comments for another learner, is what we try to say. So someone like you will understand it, and how much do you need for you to understand it, that kind of thing. But I haven't really run into a big problem on that, so yeah. Thank you for your question.